Welcome back to the second part of Trig 6.2 notes. We're continuing to work with parabolas. Let's look at this equation here. What I'm noticing is that the y value is the term that's being squared, so I know that it has to be in this form. Y minus k quantity squared equals 4p times x minus h. Again, it's important that I identify which form it's in so I know whether this parabola is opening left or right or up and down. And when the y is squared, it's opening left or right. So I have to figure out which one it's going to be in just a minute. I'll be able to do that once I know what p is. So my vertex in this problem is the hk value. And in this problem, I know that the h value is a 5. And the k value, it says positive 1/2 here, so it's really a negative 1/2. So let's take a second to plot that. If I go over 5, 1, 2, 3, 4, 5, and down 1/2, I would have my vertex right here. To find my p value, one of the reasons I write this equation right above it is so that the 2 and the 4p line up with each other. So I can write an equation out of that, and I can solve, and I can find that 1/2 is what the p value is. So since p is a positive 1/2, positive means that it was going to go right, negative would mean it would go left. I know that this parabola is going to open to the right. So from my vertex here, I need to move over 1/2 to get to the focus point. So if I'm at 5 and move over 1/2, I'd be at 5.5 now. So that's my focus. So what's the coordinate point of that focus? Well, I went over 5.5 and I went down 1/2. And really, when I did this, I should have this as moved down a little bit here, because it looks like I put it right at 1. If this is where 1 is, this is about where 1/2 is. Negative 1 there. So I know that my focus was 5 and 1/2, comma, negative 1/2. And now to find my directrix, again, what I know about my graph is that it's going to wrap around the focus. So if it wraps around the focus, the directrix has to move left 1/2. So if I move back 1/2 from here, this is from 5, I move back 1/2, I'm at 4.5. It's got to be the equation x equals 4 and 1/2. It's x because it's crossing the x-axis here. It's not crossing the y-axis. So it's the x value. So again, I recommend when you draw these, or when you are trying to figure out vertex, p, focus, and directrix, make a quick sketch of the graph. That's going to be very helpful. Okay, our next equation is a little bit different. I don't have it in the right form where I have it just as a y minus k quantity squared or an x minus an h quantity squared. But what I do notice is that I do have a y value that's being squared, so I'd like it to eventually get to this form, where it's the y value being squared, then it's equal to the 4p times the x minus the h. So with that being said, in order for me to get this equation to look like this equation, a couple things come to mind. Is that first thing I want to do is have only the y's on one side, and then move everything that's not a y over. And then I have to figure out how to get this as a binomial being squared. So the process for that is the completing the square method. So if we complete the square, I'm going to first isolate the y's. So I'm going to take these two terms that have a y, I'm going to keep them on one side of the problem, put a blank on the other at the end of it to complete the square, and then move the 8x and the 25 away to the other side. So I'd have to subtract the 8x, and I'd have to subtract the 25. And then I want to put a blank here to figure out what number I have to add to complete the square. So if you're not familiar with the completing the square process, remember that you want to make sure that this has a coefficient of 1 in front of it. If it does, you take 1/2 of the b term, and then you take that answer and you square it. So 1/2 of the b term is the 6 here. The b term in in these problems when it's a quadratic is the term in front of the y or the x. So half of b is 6, and half of 6 is 3, and 3 squared is 9. So 9 is really what I'm adding into my problem. So I add a 9 to this side to balance my equation. Now I deliberately wrote it like this, half of 6 and then 3 squared, instead of trying to do it all at once, because this 3 is the number that I'm going to go back to use when I go to complete the square here. It's going to be y plus 3 quantity squared, because I'm asking myself what multiplies to be 9 and adds to be 6. It'd be 3 and a 3, so it would become a y plus a 3 and a y plus a 3. Well, the shortcut to not having to do all of this is to recognize right away that this 3 is the number that will work for it. So that's how I was able to write this as a y plus 3 quantity squared without having to think about all of this. And then over here on this side we'd have a negative 8x and then minus 16. Okay, so again my process is trying to get this to look just like this equation here. If it's helpful to you, go ahead and write that generic form underneath it. I find that it's helpful in getting things to line up and so I can figure out what I need to do. So this side is pretty good. I've got that y minus k quantity squared, but I don't have this 4p times an x minus h. I've got negative 8x. So what I'm going to do here is I'm going to factor out a negative 8. So let's see, I'll write that over here. Factor out negative 8, so I can get this just to be an x plus or minus something. So if I do that, this becomes, this side won't change. Factoring out a negative 8 leaves me with an x plus a 2. Now I can get it so that I can line these up and recognize that 4p is equal to negative 8. So p would be equal to negative 2. And my vertex also is lining up with each other. H would be a negative 2, and k would be a negative 3. Again, remember, because both of mine are positive, it's opposite signs because they're minus in the generic form of the formula. So again, the generic form is this one. Okay, so let's go ahead and plot our vertex. Negative 2, negative 3. This is one that's going to open left or right because it is a y squared. And more specifically for this one, if our p was negative, it's going to open to the left. So take your vertex and move it over 2 now to get to your focus. So focus, and this red dot was my vertex. So I know my graph is going to be opening to the left like this. So what is the coordinate point for the focus? Looks like it's negative 4, negative 3. And then finally, to find your directrix, if your p, if you went to the left 3, to the left 2, you're going to move to the left, to the right 2. So again, let me say that again. I moved p this way, I moved left 2, so now I need to move right 2 and get my directrix. So that would be right here, and it would be this vertical line, which happens to be the vertical line x equals 0. Okay, looking at the next problem, I'm first going to identify which value is being squared, and I'm noticing it's the x value that's being squared. So I know that the generic form that I'm going to use is this form. And again, this is the form where it's going to either open up or down. And I'll figure that out as soon as I know whether the value of p is positive or negative. But this form that I have it in doesn't really look anything like this form. What I want to do is take the equation that I'm given. I'm going to rewrite that down here. And I really want to put all of my x terms on this left-hand side and all my y terms and non-y terms on the right-hand side. So I'm going to move this over here, the two x's over to this side, and I'll move this y over to this side. So doing that, I'd have to add the 1/2 x squared. I'd have to add this x, and then I would have to move the y over by subtracting it. So I'm going to end up with that. So that's the first thing to help me get this into the form that's going to be usable or user-friendly. The second form is I got some fractions here, so I'm just going to choose to eliminate the fractions. So I'm going to multiply everything by 2 to eliminate the fractions. So with that being said, it's going to become x squared plus 2x equals negative 2y plus 1. So this is now really the form where I can actually work with this and complete the square. So let me do that up here. Completing the square, on the x side we add a blank, on the non-x side we would add a blank as well. And because all of my x terms here, or this x squared term starts out with a 1, we can go ahead and take, do that up here, half of the b term, so half of 2, which is 1, and then square that, which would be 1. So I'm going to add a 1 to this blank and a 1 to this blank. So again, this 1 that I got right here is what I would use when I try to figure out what multiplies b1 and adds b2. That'd be 1 and 1. Over here, it'd be 2y plus 2. Okay, so again, I'm trying to keep this form in mind. Remember that I really want this to just have the y by itself, so I need to factor out a negative 2. So if I factor out negative 2, it's now going to look like this. This left side doesn't change. And now I have it in the right form where I can actually work with it. So if I just write the generic form underneath it, we'll see some things start to line up. My h is a negative 1, and my k is a 1. So my vertex is negative 1, 1. So there's my vertex. My p-value, I can find that by writing the equation negative 2 equals 4p. So if I divide by 4, I get p to end up being negative 1/2. So if p is negative 1/2, and it opens up or down, p was negative, so it's going to open down. So from this v of negative 1, 1, I need to move down 1/2. So I'd put my focus right here. So that coordinate point is negative 1, and then I went up 1/2. Now the directrix, what will happen with the directrix, if I put a couple more lines up here, is the directrix will end up going up 1/2 from my vertex. So I think what I'm going to want to do is, well, I'll just use a different color. If I go up 1/2, that'd be right about here. And because my graph is going to open around the focus, I know my directrix would have to go through this way. So this is the equation. Now it's going through the y-axis at 1.5. So y equals 1 and 1/2. So again, this one seemed a little bit more difficult because I wasn't given a nice form of my equation. I recommend that when you're trying to complete the square that you move all the x's or the y's, whichever are being squared, over to one side, move everything else over to the other. And if you have fractions at all, try to multiply through to eliminate the fractions. It makes your work a whole lot easier if you can go through and eliminate the fractions right off the bat. Now it becomes a pretty simple completing the square problem to solve.